So the IPv6 protocol is used for to replace the IPv4 protocol. So IPv4 protocol had many not disadvantages but limitations like address space, especially. So it is developed to. So see here, developed to address the limitations of IPv4. It has a limited, larger address space size and introduces several enhancement and changes to the functionality and efficiency. So what are the key changes? Better header. So it has a better new header unlike the IPv4, and it is not and from the base header. So 40 byte of new header. New options, additional functionalities can be enabled through new options. Allowance for extensions, allows for protocol extensions for future emerging technologies. Separate resource allocation. The type of field is replaced by traffic class and flow label for better handling in real-time traffic. Enhanced security. It provides encryption mechanisms. So the packet format we have to talk. See, it consists of a 40 byte base header, as we can see here. So see here, this is actually required for us. So 40 byte base header, and the payload is of a length up to 65,353, 65535 bytes. See here the breakdown of its components. So version, it is a 4-bit, indicates the version of IP. So don't misunderstand this 4 and write the version is 4. It is the bit size, okay, bit size. So it is 4 and IPv6 version is 6. Class, it classifies the packet for different delivery requirements. So whatever the packets are there, it classifies them for different delivery requirements. Flow label identifies the data stream for special handling. Payload is nothing but defines the length of the data. Payload length defines the length of the data. Payload is the actual data up to 65,535 bit. Flow but identifies data streams for special handling. So whatever the data streams are, it identifies that for handling. Next header is the next type of the header. Type of the next header. So hop limit is nothing but similar to TTL, time to live. Hop limits limits the number of hop limits. So data cannot be there forever, so it limits it. So and destination address of 128 bit specifies the sender address and specifies the receiver. The payload can include 0 or more extension headers followed by the data from the other protocols. The extension headers uses additional functionalities for fragmentations. So you have the flow and priority. Flow label helps to treat packet in similar character such as real-time traffic in a special way, speeding up the process and routers. Connected oriented support introduces concept like flows for allowing more structured handling of traffic. Fragmentation and reasonably source side fragmentation, extension headers. So this thing just read once. Now comparison between IPv4 and IPv6. So see here, address length IPv4 32, but here 128 bit, 340 and decillion. Wow. Address format dotted decimal, here hexadecimal with colons. See, colons are there. Dots. Here just don't dot. Address space limited, not enough for global usage. Vastly expanded, can accommodate a large number of devices globally. Header complexity more complex with many fields. See, and that header so many fields. Here header is separated from all the other things, and only base separate header is there. Packet fragmentation occurs at board and sender routers. Only occurs at senders. Routers do not fragment. So here both senders and routers are doing fragmentation. Here only sender. Routing efficiency, manual configuration at NAT. Here see, here actually NAT is there for routing. Here NAT is there. So here simplify routing with auto configuration, more efficient routing due to larger address space. Security, optional and address through IP security. Here built-in security are there like IPv6 for providing encryption and authentication. Network configuration requires DCHCP or manual configuration. It uses stateless addresses, SLA auto configuration, but automatic address assignment. Quality of service limited, and here improved address depletion, exhausted due to limited address space, no address depletion. NAT requires to manage. NAT is typically not there here. Network address. Okay, so translation. Network address translation requires to manage addresses as such. Here not required due to AMP is broadcasting. Same way, just ready this protocol complexity, mobility support, multicast support is optional and it is mandatory. So key advantages of here, that's tabular format. Here it is in serial format. But larger space, simplified header, built-in securities, auto configuration, efficient routing, no need of NAT. So this is more than enough for you to understand IPv4, IPv6 and advantages of it over IPv4. So we'll move on to the next topic in the next lecture.